Hello, my name is Bryan, and my partners are William Gagne and Carlos Polanco. Our drawdown topic subject was electricity, and our solution was offshore wind power. Offshore wind power is the deployment of wind farms placed in bodies of water such as the sea, lakes, and fjords. Offshore farms generate more electricity due to higher wind speeds compared to on land. Most offshore wind farms are in shallow waters with fixed foundation wind turbines. However, floating wind turbines for deeper waters have been in the early stages of development, with a few of them deployed. With the growth of offshore wind turbines, it is estimated to avoid 10.4 to 11.4 gigatons of greenhouse gases in the future, with a lifetime savings of over 600 billion in US dollars. The first offshore wind farm, called Vindeby, was installed in Denmark in 1991. Henrik Stiesdal had the overall responsibility for the farm and is involved in around 175 inventions and a major part of to the offshore wind power. Some of his inventions were the integral blade technology, which eliminated weak spots from the previous installations. The combi stall blade regulation system was fully implemented in their megawatt range turbines. Variable speed turbine for bonus energy. Direct drive technology eliminated the gearbox, which was the weak spot of the traditional wind turbine designs, and the thermal storage, which led to a higher storage capacity than the latent heat storage it had previously. While the US has a developed onshore wind industry, they did not install their first offshore wind facility until 2016, called Block Island Wind Farm. Europe is the world leading in offshore wind power, and as of 2020, 90% of offshore global market is represented by European companies. The pros and cons. For the first three pros and cons, it's the difference between offshore wind turbines and onshore wind turbines. They have faster wind speeds. A turbine of 15 miles per hour can generate twice as much energy as a turbine in a 12 mile per hour wind. They tend to be steadier. Steadier supply of wind means a more reliable source of energy, and we have high population coastal areas. Half of the U.S. population lives in coastal areas with high energy needs. As I said, the rest of the pros are shared with both on and offshore turbines. They provide renewable energy. They do not consume water. They create new jobs, and they do not emit environmental pollutions or greenhouse gases. The cons are they can be expensive and difficult to build and maintain. It is hard to build wind farms in water deeper than around 200 feet. However, floating wind turbines are beginning to overcome this challenge. Wave action and extreme wind conditions during heavy storms or hurricanes can damage wind turbines. Production and installation of power cables under the seafloor to transmit electricity back to land can also be very expensive. And last, tourism and property values may be affected since they are built up to 26 miles offshore and can still be seen. I will now pass on the presentation to Carlos. Thank you.
Thank you, Christian. There are many companies that produce wind turbines in the world, but some are much more prevalent than others. Take Vestas, for example. They are the largest producer of the top five and have a capacity of 9.60 gigawatts. That's 1.5 times more than Envision, the fifth largest wind turbine producers. The second largest producer of wind turbines is Siemens Gamesa, which has a total of 8.79 gigawatts, which is just above its competitors Goldwind with a total capacity of 8.25 gigawatts and GE Renewable Energy with a total capacity of 7.37 gigawatts. Siemens Gamesa is one of the largest wind turbine producers and the global leader in the offshore wind market. They were formerly known as Siemens Wind Power and Gamesa Corporación before their merger back in 2017. These two massive titans have an incredible track record, such as the completion of the first ever offshore wind project known as Vindeby Offshore Wind Farm, which Christian had actually mentioned earlier, and this was completed by Siemens back in 1991. As of now, Siemens Gamesa has more than 160 operational offshore power plants all over the world, including one of their most recent projects known as the Hornsea Project 1, which was completed back in January of 2021, with a capacity of 1,218 megawatts, making it the largest offshore wind farm in the world, with the capacity to power more than 1 million homes and producing 15% of UK's wind power alone. All this growth in the offshore wind is only going to accelerate over the coming years, with Siemens Gamesa's predicted global outlook of 200 gigawatts by 2030. And now I'll be passing it off to William.
Thank you, Carlos. My name is William Gagne, and this is a recap of electricity with respect to greenhouse gas emissions. So, electricity contributes 25% or a quarter to the total U.S. greenhouse gas emissions by economic sector, and that's in the top graph right here. And activities involve generation, transmission, and distribution of electricity. We're going to call these the main drivers of greenhouse gas emissions from electricity. Wind turbines directly benefit the generation activity of electricity, so that's saying if we burn less fossil fuels to get power, if we replace it with renewable energy, then that's much better for the environment. This would also reduce greenhouse gas emissions from our end-use activities of energy. This could be things like appliances, air conditioning, or charging your electric car. So offshore wind turbines are greater than wind turbines. There are several advantages of using offshore wind turbines. Some locations are more efficient than others, and this could be attributed to the speed of the wind for efficiency or the timing or gusts of wind. They can be scaled up when compared to onshore turbines. They can be used in shallow or deep water, and this is attributed to their floating or fixed structures. And electricity demanded concentrated on the coasts, and this is another reason why offshore wind turbines are viable, is because the distance from their electrical grid where they need to go to them is short because it's in the water and on the coast. So, as I stated earlier, the scaling up of offshore turbines, we have smaller ones on the land and then larger ones in the water, just shows that it can be scaled up. 5 megawatts can power a few thousand homes in real time. And more of the numbers is the idea of scalability, and it's only going to get larger. So, fixed innovations of offshore turbines. Different approaches are used for fixed turbines for different situations, but they all need to be built up from the ocean floor, and they're more stable than floating turbines, but they're usually more costly and labor intensive. So, flotation innovation of offshore turbines. As with the fixed, there are many different approaches to the flotation of offshore turbines, such as the semi-submersible and the tension leg, but they all connect to the electrical grid via underwater cables, and these the floating ones have the ability to go deeper into waters than compared to their fixed counterparts. So here are two examples of offshore wind turbine farms. Dogger Bank Wind Farm, which is developing on the left, and that's the largest one right now. And then we have the second largest wind farm, Borselli, which was developed in 2020. And I also thought it was interesting that they were both in the North Sea, so it could be due to a good location there. And as Carlos stated earlier, two of the largest corporations, GE and Siemens Gamesa, are backing these projects, so they're only getting larger. So a question we wanted to ask everyone was, what would it take for you to get involved? So we all agree, scientists, the society, everybody, that climate change is an issue, but what can we do? What's a concrete solution? So one solution is donating to either cleanegroup.org or caoffshorewind.org. So Clean E-Group is more focused on replacing fossil fuels and dirty power with renewable energy, and CA Offshore Wind is more focused in on what we're talking about, California and offshore wind projects. So windexchange.energy.gov was another really good resource because it shows you training and education for the wind energy workforce. So we can actually get careers for sustainability, which is important. And one thing we should all do, because we can, is write a letter or petition to your public official. And this is important because if we can get it into everyday society and make policies that are important to the environment, then and they know we are all behind it, and then it might be incorporated in the political agenda. And that's it. Thank you so much, everybody.